Welcome to my presentation. In this presentation, we are continuing from part 1. We are trying to solve system of linear equations using matrices using the Gaussian elimination method, and this is part 2 of that problem solving. In this presentation, we will show you how we can solve system of linear equations using graphical method. So the linear system of linear equations we had was as follows. Let's write that down one more time. And the system of linear equations was x plus 3y is equal to -1. In the previous example, in part 1, I called it as x1 and x2. Here I'm going to call it as x and y. And then the second equation we have is 2x minus y is equal to 3. And if we call this as equation number 1 and we call this as equation number 2, we want to write these given equations in the standard form of a straight line. And how do we do that? Let me show you this. Step number 1. We'll take one equation at a time and then try to write them out in the standard form. So the first equation reads as follows, isn't it? X plus 3y is equal to -1, and then 3y is equal to -x minus 1 by using the addition property. We want to write it out as y equals to y is equal to -x over 3 minus 1 over 3. It is now in the standard form y is equal to mx plus b. That is the standard form of a straight line. And once we have it in this form, we want to be able to recognize the slope of the equation and the y-intercept of the equation. The slope is represented by m. M in this case is -1 over 3. And the y-intercept, which is represented as b, is equal to -1 over 3. And that is all we need to be able to represent the given equation, x plus 3y is equal to -1. Okay. We will also get the second equation down in this format, and then we will go to a graph and then draw it out. The second equation, what is given to us, is as follows: 2x minus y is equal to 3, and I can rewrite this as -y is equal to 3 minus 2x, or I can also write this as y is equal to -3 plus 2x, same thing. Or I can also write this one as y is equal to 2x minus 3. And this is in the standard form, y equals to mx plus b. And we want to identify the slope in this case. The slope in this case is 2 over 1. And then the y-intercept in this case is going to be equal to -3. So we have identified the slope and y-intercept for the first equation. We have identified the slope and the y-intercept for the second equation. And now we are ready to represent this in a graphical manner. So let's draw a graph here. This is not going to be very pretty, but at the same time I want to explain how this graph would look like. Okay, so let me say this is my graph, and I'll take some points on this one is the positive x-axis, this is the negative x-axis, this is the positive y-axis, and this is the negative y-axis. So the point where both these axes meet is the origin, so we'll call that as 0. And then we'll pick some points here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. If we need more points, we'll come back and then locate them. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. And then on the y-axis, we'll pick some few points, positive 1, positive 2. And on the negative y-axis, we'll pick some more points. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. If we need, we'll call that as negative 7. I'm going to use different colors to represent these two lines. For the first one, I'm going to write this out as, let me say, the first one I want to represent the slope and the y-intercept. The way we do that is as follows. First we identify where the y-intercept is, and in this case negative 1 over 3 means that number is going to be equal to negative 0.33. So if I were to just say 0.3 for convenience sake, 0 to negative 1, if I'm looking at the negative y-axis and I want to locate 0.3 on the negative y-axis, so it would be very close to the origin, and I'm going to put a circle around it. And once we've identified the y-intercept, we want to superimpose the slope on top of that. So the slope here, we can also write this one as negative 1 divided by 3. The slope is a representation of rise over run. When we have rise as negative 1, we're going to go down 1 unit. So this is 0.3. So if I want to go down 1 unit, I'm going to go down 1 unit like that. I'm going to travel downwards, put an arrow there, and then the run is 3 positive units. So from here, I'm going to count 1, 2, 3 units to the right, put a dash line, and then put an arrow indicating that is the direction we travel. And wherever we end, we'll put a circle around it, and we want to join these two with a straight edge, like that. We have identified the 2 points and we've drawn a straight line. And this line here, this line here is the representation of x plus 3y is equal to negative 1, or that is in the non-standard form, or in the standard form this can be represented as y is equal to negative x over 3 minus 1 over 3. Okay, so this is how we can think about it, represent a graph by knowing what the y-intercept is and what the slope is. We'll do the similar thing for the second equation. And we have already identified the slope and y-intercept for that. Let me pick another color here. This time I want to pick blue, and if I were to pick blue here, this is M and that is B. So first we will identify where the y-intercept is. B is the y-intercept. So negative 3 units. That negative 3 means y-intercept is always a point on the y-axis. Negative 1, negative 2, negative 3. Right on the y-axis, there, right there. And then from here, we want to superimpose the slope on top of that. M is rise over run. We're going to rise 2 units. So that means we're going to go up 2 units, like that. Put an arrow there. And we're going to go run 1 unit. Run means we're going to run on the x-axis and rise on the y-axis. So we go to run 1 unit on the x-axis, and then we put a circle there, and with a straight edge we're going to connect these 2 points. With a straight edge we're going to connect these 2 points, and when we do that, and when we extend it on either side, we see that there is a point of intersection. I'm going to use another color now. We're going to there is a point of intersection which is slightly above there. I'm going to put a circle there, and I've put a circle and then indicated by a red dot, and that red dot is called the point of intersection, and that is the solution point, pretty much. That point is that point of intersection satisfies both these equations. Before I go further, let me also illustrate name this line, which is 2x minus y is equal to 3, and then that is in the non-standard form, or in the standard form we can also write this one as y is equal to 2x minus 3, like that. Okay, so now that we have all the information we wanted, if I wait to we have the point of intersection, but the point of intersection, from the point of intersection we should be able to identify what the x ordinate is and what the y ordinate is. If we were to draw this to scale, and then if we were to project the point onto the x-axis, that is the point we are interested in, and if we were to project it onto the y-axis, that is the point we are interested in. So as you can see here, the point is slightly to the right of unit 1, and then on the y-axis the point is slightly less than -1. So these, if I drew these points to scale, you can always do this. You can take a graph sheet and then draw them out, and then you will see that. And these points, by the way, would be the following points. X, since this is slightly greater than 1 and less than 2, this point here could be, I'm going to write this one as, this point here could be 1.14, which is same as 8/7. And then on the y-axis, this point could be, I'm going to write it out here, could be -0.71, or it could be -5/7. Therefore, the point of intersection, this point here, can be represented as 8/7, comma -5/7. The x ordinate is 8/7 and the y ordinate is -5/7. This is the way we can represent it in a graphical manner. In my next presentation, we shall look at some more examples to see how we can solve system of linear equations using some advanced methods.